You added jitter, closed the ticket and moved on. Every one of those retries still arrives. Backoff changed when they land. It never changed how many. And your service isn't the only thing in that request path running a retry loop. The client has one, the gateway has one, the driver has one. They don't add up, they multiply. Google's own SRE book does this arithmetic for you. 3 layers stacked above a database, 4 attempts each. 1 user action, 64 attempts on that database, not 4, 64. Start with what that looks like when it happens to an actual cloud provider. October 19th, 2025. A DNS fault knocks DynamoDB offline in US East 1 just before midnight. AWS has a DNS problem fixed by 2:40 the next morning, so the trigger's gone. The outage isn't. EC2 has dropped into what AWS calls congestive collapse and it sits there for hours. Look at the shape of that. The fault itself ran 2 hours and 52 minutes. Network load balancers stayed degraded for 8 hours and 39 minutes. EC2 wasn't fully healthy until 10 to 2 that afternoon. Short trigger, very long queue of retried work behind it. Now look at what actually stopped it. At 14 minutes past 4 in the morning, engineers throttled incoming work and started restarting hosts. That's the fix. Not a longer delay, not more jitter, a human turning the volume down, because the system couldn't turn itself down. So here's the thing, almost every backend team has already built to prevent that. This is the path a request takes through a fairly ordinary service. Browser to gateway, gateway to your API to the database. 4 hops, 4 different code bases. Hold on to this picture because every one of those boxes has an opinion about retrying. And the opinion looks like this. Try the call. If it fails, wait. Double the wait each time. Add a random offset so 1,000 clients don't all wake up on the same millisecond. Cap it at 3 attempts. It's about 15 lines. It ships in every language's standard toolkit and it's genuinely good code. The loop's simple enough to draw. Call, fail, sleep for 2 to the attempt number plus a coin flip. Call again, 3 tries, then give up and return the error. Most teams write this once, drop it in a shared library and never look at it again. And to be clear, jitter works. It fixes a real problem. Without it, every client that failed at the same instant retries at the same instant in lockstep forever. Randomizing the delay breaks that synchronization. Mark Brooker at AWS wrote the post that made this standard practice, and he was right. The SRE book actually gives 3 pieces of advice about retries. Always randomize your backoff. Limit the attempts per request. And decide whether you really need to retry at this level at all. Everyone shipped the first 2. Almost nobody does the third one. Because the third one needs a conversation with another team. Which brings us to the part the shared library never tells you about. Go back to that request path. Switch on the retry logic that's already sitting at every level of it. The browser's fetch wrapper retries, the gateway retries, your service retries the call to the database, the driver retries the connection. Nobody sat down and configured all 4. Each one was a reasonable local decision. And most of those layers aren't your code, which is why nobody audits them. Your HTTP client library retries, your service mesh sidecar retries, your database driver retries, your job runner retries, your cloud SDK retries. Every one of those defaults got picked by somebody who couldn't see the other 4. So the attempts don't add up, they multiply. The number of calls reaching the bottom is the product of the attempt counts above it, never the sum. 3 layers, 4 attempts each. 4 times 4 times 4. 64 calls off a single click. Watch it climb. 1 request at the top, 4 leaving the gateway, 16 leaving your service, 64 hitting the database. That's Google's own example, and they bothered to write it down because they kept finding it in their own systems. So what did Backoff do to that number? Nothing. Without it, 64 attempts arrive inside 2 seconds. With Exponential Backoff and jitter, 64 attempts arrive spread over 30 seconds. Same 64 calls. Same total work handed to a database that already can't keep up. You moved the traffic along the time axis, the volume sat exactly where it was. Backoff is a scheduling change. Overload is a volume problem. Which raises the obvious question. So why doesn't that delay help? It depends entirely on who's calling. If your callers are a fixed pool of workers pulling off a queue, backoff really does reduce load. A worker that's asleep isn't sending anything. 10 sleeping workers means fewer requests per second, and that's real. But if your callers are a million browsers, sleeping changes nothing. They each still send their 3 attempts. They just send them a little later. Almost every public API lives on the wrong end of that line. Your callers aren't a bounded pool you control. They're an open set and they turn up on their own schedule. Their number climbs at exactly the moment something interesting is going wrong. Here's the mechanism, straight out of a real postmortem. September 2015, DynamoDB. Storage servers ask a metadata service for membership data. A brief network blip makes those responses slow. A storage server that doesn't get an answer in time retries and pulls itself out of service. Those retries pile onto the metadata service. Now it's slower still. Now healthy servers start missing their renewals too. And this is the part that should worry you. Servers that had already succeeded were transitioning back into an unavailable state. The retry traffic wasn't merely failing to recover the system, it was converting healthy machines into fresh sources of retry traffic. That's positive feedback. It's the exact shape Google's book names as a cascading failure. Alright, let's put some numbers on what a budget's actually worth. The SRE book gives you 3 data points. With no limits at all, retries multiply your load 64-fold in that 3-layer example. Cap every request at 3 attempts and the growth drops to 3-fold, which they describe correctly as still significant. Add one more rule, it drops to 1.1. That rules a ratio. Every client tracks what fraction of its outgoing requests are retries. It refuses to retry while that fraction sits above 10%, not a delay. A quota. 9 out of every 10 requests leaving your process have to be first attempts. For scale, in that 2015 DynamoDB event, the customer-facing error rate settled around 55%. AWS said that was far beyond anything they'd seen in 3 years, more than half of every request failing 4 hours on a system that already had backoff. Mark Brooker put the whole argument in one sentence. The only way to deal with long-term overload is to reduce load. Deferring load doesn't work. Backoff defers. That's the entire distinction. So, if the delay isn't the lever, he's the one that is. A retry budget caps the ratio of retries to requests over recent history, not per call, across your whole client. Once that ratio is blown, the next failure comes straight back instead of trying again. Retrying stops being something one call decides and becomes something the process rations. There are 3 mechanisms here and you want more than one. An attempt cap stops a single runaway call. A retry budget caps what your whole process contributes to the storm. And server-side pushback lets an overloaded backend tell its clients to stop. That's the only one that scales across 10,000 machines. Pushback is worth understanding because it's the piece almost nobody has. Google's clients stamp the attempt number into the request metadata. Backends keep histograms of it. When a backend sees a lot of retries in that histogram, it stops answering with try again. It answers with overloaded, don't retry. The server sets the budget. Good news, you probably already have this. gRPC ships retry throttling as a token bucket in the service config. Every failure spends a token, every success returns a fraction of 1. Retries switch off completely while the bucket sits below half. Envoy exposes the same idea as a percentage of concurrent requests. Before you tune anything though, measure. Envoy's admin endpoint will hand you retry counts per cluster right now. Divide retries by total requests. If that number is above 10% on an ordinary Tuesday, you don't have a retry policy. You have a retry-storm with good manners. AWS agrees with this hard enough to change their defaults. In May 2026, they announced new retry behavior across every SDK. A 500 token budget. 3 attempts, 4 for DynamoDB clients. You can opt in today with an environment variable. It becomes the default in November 2026. And it does cost you something real. When the budget spent, calls that would have succeeded on a second attempt now fail straight away. You're trading individual request success for whole system recovery. That's the deal. During an incident, it's obviously the right trade. On a normal day, the budget never engages at all. One idea to carry out of this, if you carry nothing else. Stop treating a retry as something your core gets to decide. Every retry is a withdrawal from one account your whole stack shares. The client draws on it, the gateway draws on it, your driver draws on it, and not one of them can see the balance unless you hand them one. You added jitter and closed the ticket. The jitter was fine, the ticket wasn't. Go find every layer sitting between a user and your database. Count the attempts each one will make and multiply them together. Then decide what ratio you're willing to spend and enforce it. That's a retry policy. Everything else is scheduling.